Hi everyone, welcome to our video on how do we find the volume of a rectangular prism. If you would like to read the do now and give it a try, please pause the video and resume it when you are ready for the answer. Do now. Use the calculator to find the width of the rectangular prism if the volume is 80 cubic centimeters. Keeping in mind that the formula for volume of a prism is length times width times height. So here we have a rectangular prism, and we are given two of the dimensions, and the question is asking for the third dimension because the volume is being given to us. So I'm going to write down our formula. Volume equals length times width times height. And I don't really care what I call each of these dimensions. For the purpose of this, I'm just going to call this a length and this a height. Remember, all of these can be interchangeable because the formula will hold true due to the fact that multiplication is commutative. So, since we're considering 6 2/3 to be the length and 2.5 centimeters to be the height, I'm going to substitute my values into the formula. We know the volume is 80 cubic centimeters. I'm going to write down 80 for the volume. The length is 6 2/3. The width we don't know. I'm going to put that at the end. We talked about why we do that. It just makes sense that the variable we're solving for goes at the end of our equation. And I'm going to put the height 2.5 centimeters. So before I can go ahead and proceed with this equation, I need to multiply 6 2/3 times 2.5. So I'm going to rewrite 80 equals. Now I'm going to do 6 2/3 times 2.5. Remember, we have to use the ABC key to make a fraction. So 6, ABC 2, ABC 3, that's our fraction button, times 2.5. We get the decimal 16.6666666. We know what that is. That's 16 2/3. If you want the calculator to show you that, remember, you can hit second decimal to fraction to be told that it's 16 2/3. So 6 2/3 times 2.5 is 16 2/3 W. So now in order to solve for W, we're going to use our inverse operation. 16 2/3 and W are being united with multiplication. The inverse of multiplication is division. I'm going to divide both sides by 16 2/3 to get my final answer, 80 divided by 16 2/3. I get 4 4/5. Don't forget our units. These are centimeters. Awesome. All right, moving on with our notes. So today we're going to talk about how we find the volume of a rectangular prism. So first I'm going to write down the formula that we use, which we've seen before in the past. Volume equals length times width times height. We have another way to find the volume of a rectangular prism, and I'm going to explain that now. So volume equals, we know, length times width times height. Those are our abbreviations. Or volume equals capital B, or as I like to say, big B, times H. Now, what this big B stands for, if you want to write a little arrow in your notes, it stands for the area of the base. Now, the reason why this makes sense is because if we're talking about a rectangular prism and we are thinking of our formula as big B times H, if big B or capital B stands for the area of the base, well, the shape of the base that I'm outlining here of a rectangular prism is a rectangle. And we know the area of a rectangle is length times width. So that big B really is length times width. length times width, and then we tack on the height. That's why it's the same formula. But we're most likely for now going to stick with length times width times height. But it's good that you know how to do that. So these two rectangular prisms as examples, I'm going to complete right now, just as practice. So for this rectangular prism here, I'm going to write down my formula. Volume equals length times width times height. Volume equals, I'm going to substitute the length here. And once again, it doesn't really matter. I'm going to write down the dimensions that I think make sense visually, but multiplication is commutative, so it doesn't really matter. The length is 6. The width is 4, and the height is 7. We're going to use our calculator now that we're allowed to do so. 6 times 4 times 7 is 168. Don't forget that volume is in cubic centimeters. Our second example. I'm going to write down my formula again. Volume equals length times width times height. Volume equals, time to substitute. The length is 4 units, the width is 3 units, and the height is 2 units. Multiplying all these things together, 4 times 3 times 2, we get 24 units cubed. Forgot to box my answer over here. Awesome. Now, just as an added note here, we can find the volume of a cube the same way we find the volume of a rectangular prism, because cubes really are rectangular prisms, but all of the sides happen to be the same length, which is what makes it a cube. So you can use the formula for volume of a rectangular prism to find the volume of a cube, length times width times height, but we also just consider each of those lengths, widths, and heights as sides, since they all have the same value, since it's a cube. So we can use the formula side times side times side, or to consolidate that, we use an exponent side cubed. So sometimes when we find the volume of a cube, we're going to use the formula volume equals side cubed. All right, let's try some questions together. Find the volume. So what we have here is a cube. We can tell because each of the sides are the same length. So when solving this, I'm going to use side cubed. Volume here equals, we know the length of one of the sides here is 1/5 of an inch cubed. All I've done is substitute. And then I'm going to use my calculator to get my answer. Remember, we can use the caret button in order to evaluate an exponent. So I'm going to do, in parentheses, 1/5 to the third, which is 1/125th. 1/125th inches cubed. Box our answer, and we're done. Number 2. This is a rectangular prism, so I'm going to write down my formula, volume equals length times width times height. Now, don't be fooled. This looks like, just by the dimensions given, that this could be a cube because all I see is a bunch of 1/4 centimeters. But look at what that's pointing out. It's just saying that the length of one of these cubes is 1/4. So we have to do a little bit of legwork here to figure out what the length, width, and height actually are. We can tell that the height is 1/4. That makes sense. But let's just say this is the width that I'm pointing to here. That's 2 cubes in width. So that's 1/4 plus another 1/4 to make 2/4. Now our length, that's a whole bunch of cubes. 1, 2, 3, 4, 5, 6. 6 1/4 cubes, or 1/4 times 6, is 6/4. So this length is 6/4. Now that we know the dimensions of our rectangular prism, we can substitute them into our formula. So the length is 6/4 times the width of 2/4 times the height 1/4. The volume here equals, once again, you don't have to use your calculator. I'm going to use it because I have it here. 6/4 times 2/4 times 1/4. We get 3/16. And these are cubic centimeters. Number 3. Looks like a rectangular prism. Volume equals length times width times height. Volume equals length of 7 1/2. For this question, I'm going to use my dot to represent multiplication. Either way works. I've been using parentheses. Times a width of 4 1/2 times 2 1/2. Volume equals 7 1/2 times 4 1/2 times 2 1/2. We get 84 3/8. 84 3/8 feet cubed. Awesome. Number 4. Have a popcorn box here that we're finding the volume of. Volume equals length times width times height. Volume equals 8 times 4 times 11. Volume equals 8 times 4 times 11. 352 inches cubed. And we have one more question here for number 4. If each cubic inch of popcorn costs 2 cents, how much would you pay for the box of popcorn? Just remember what a volume is. A volume means the amount of space that occupies a solid. So if each cubic inch, now remember the volume of this box of popcorn is 352 cubic inches. So if each of those 352 inches costs 2 cents, to find how much you pay for the whole box of popcorn, we need to multiply 352 by 2 cents, because each of these 352 cubic inches costs 2 cents. We'll use the calculator to do this. 352 is already in my calculator, so if I hit multiply, it's going to say the answer, that's the previous number that the calculator has stored, which is 352, times 2 cents to get $7.04. Make sure we have a dollar sign, and we box our answer. Very good. Now it's time for you to try. If you would like to pause the video to give numbers 5, 6, 7, 8, 9, 10 a try on your own, I would suggest that, and then come back to check your answers on the video. All right, number 5. So we have a rectangular prism here. So I'm going to write down my formula. Volume equals length times width times height. And this is a question just like number 2 above, where they're telling us that each of the cubes here has a measurement of 1/8 of a centimeter. So we need to figure out what each of the dimensions, the length, the width, and the height are. So I'll start with the length. If each of these are 1/8, there's 1, 2, 3, 4, 5 cubes for the length. So that's 5/8. 1/8 plus 1/8 plus 1/8 plus 1/8 plus 1/8 is 5/8. And we'll jump to the width here. That's 1, 2 cubes. So I'm going to call that 2/8. And the height, I'll write it over here, is 1, 2, 3, 4 cubes high. So that's 4/8. Once again, how I knew that, 1/8 plus 1/8 plus 1/8 plus 1/8 is 1, 2, 3, 4 eighths. 4/8. Keep in mind, you may be wondering why I'm not simplifying my fractions. We know 4/8 equals 1/2. Since we're using the calculator, it's going to do the simplification for us in the end, so you don't really have to worry about that. Time for substitution. Volume equals 5/8, my length, times 2/8, my width, times 4/8, my height. volume equals 5/8 times 2/8 times 4/8. We get 5/64 centimeters cubed. 5/64 centimeters cubed. Awesome. Number 6. For number 6, we are going to assume for this question, it's a little unclear, that the length of each of these cubes is just 1. No, it's not really clear in this question, but if you stumbled upon this one when you were trying these on your own, let's just assume that each of these cubes is of length 1 unit. You can assume that when there's nothing labeled in a diagram, we just assume that each cube is 1 unit in length. So the length 1, 2, 3, 4, 5, 6 of this rectangular prism is 6 units. The width is 2 units, and the height is 1 cube unit. Volume equals length times width times height. Volume equals 6 times 2 times 1. Don't think I need the calculator for that one. 6 times 2 is 12 times 1 is still 12 cubic units. Awesome. Next page. Number 7, we're finding the volume of this aquarium. Volume equals length times width times height. Volume equals length is 3 feet times width is 2 feet times the height is 5 feet. Volume equals 3 times 2 times 5. And we get a volume of 30 feet cubed. Number 8. Finding the volume of this rectangular prism, length times width times height. Volume equals, length is 5.5 feet times a width of 4 feet times a height of 4 feet. Volume equals 5.5 times 4 times 4. We get 88 cubic feet. Number 9. This looks like a cube to me. All of the dimensions are 1/3 of an inch. So I'm going to use side cubed. That's our formula for volume of a cube. That side is of length 1/3. So I substitute it in for s cubed. And I'm going to plug it into the calculator just like I wrote it. Parentheses 1/3 caret. My power is 3. Volume equals 1/27. And these are cubic inches. Last one, number 10. Let's find the volume of this box of cake mix. Volume equals length times width times height. Volume equals, my length is 9 times 3 times 12. Volume equals 9 times 3 times 12. 324 cubic inches. And like we did together, we have a similar question here. If each cubic inch of cake mix costs 4 cents, how much would you pay for the box of cake mix? So each of these 324 cubic inches costs 4 cents. We need to multiply 324 by 0.04, which is 4 cents. So I'm going to multiply this 324 by 0.04, and I get $12.96. Very nice job. To summarize, which of the following words does not represent volume of a rectangular prism? Fill. That sounds good to me, like we're filling an aquarium with water or a tank with water. So that works. Capacity, the overall capacity, that's a word to say how much something can hold, perhaps. That does describe volume. To cover something. To me, that reminds me more of a surface area, or just the top, maybe, of some three-dimensional figure. That is not a volume. That does not represent volume. Contain, that is a good volume word. So fill, capacity, and contain, those are all good words to represent volume, but cover certainly is not. That's only one of the pieces of a three-dimensional object. All right, great job, everyone. If you have any questions, as always, feel free to reach out to any of your teachers and check in with us when we meet on the internet. Have a great day.